chair today. I'm accompanied by Ville Mertonen from Karelia University of Applied Sciences, who is the host and will take care of the technical matters. And speaking of technical instructions, let us agree that everyone keeps their cameras and microphones closed off if you're not speaking. Just to show you where to find the right buttons. This is your camera button, so if it's crossed out, it will be not showing you. I suggest that only the speakers have the camera on when they're speaking, and as an instruction, once your time is ending, I will also switch on my camera to give you a heads up that your time is up. Same with the microphone. Please, everyone, keep the microphone off so that we can have the best sound quality possible. If you have questions, please use the chat. In doing that, please introduce your name and your organization, and also write down the question to whom and what the question is. We will have at the end of the session a discussion where we can exchange different questions, or we'll pick up questions from there. Alternatively, for the end of the session, you can also raise your hand if you want to comment or raise questions. I hope we'll have a very nice and interesting discussion towards the end of this interesting seminar. This meeting will be recorded, and it will be also shared later on the Karelia University of Applied Sciences website and on YouTube. And the presentations will be also accessible later on the Karelia website under this link. We are very happy to have about 100 participants registered from all over the world, mainly, of course, from Europe, which might have to do with the topic, but also with the time zone. And I welcome you all. Without much further ado, I want to start directly on the program. Forest area in Europe is about 33% of the land area, equaling some 250 million hectares. Of this, annually, about 268 million tons are harvested annually. Looking at timber, the chemical composition of timber is 50% carbon, carbon that can be stored either in the forest or in the products. The longer the products are stored in terms of lifetime, the longer is the carbon storage potential. And that means that the carbon is out of the natural cycle. What this means in terms of forest-based bioeconomy and substitution potentials, Pekka Leskinen will elaborate in a joint presentation with Vreese, who will in turn elaborate on forests and timber and urban planning. Going further to the built environment, we'll have a presentation by Matti Kuittinen. The building sector accounts for 36% of the final energy use and 39% of CO2 emissions globally, as well as half of the materials used. Lowering the energy consumption of buildings is imperative, and all new buildings in the EU should be near to zero energy buildings by 2020. Timber as a local and renewable material can play a significant role. However, currently only about 58% of detached residential houses in Finland are built from timber, and when it comes to multi-story buildings, it's only 3.5. So this type of construction builds an opportunity for construction, but also for renovation and for refurbishing. And against this background, Matti Kuittinen will elaborate on the carbon footprint. Coming from a city administrative perspective, Satu Turula will detail the implications of fostering public procurement with considerations towards low carbon, in a city context. To give an insight from practice, Mika, Keskisalo and Mikko Matveinen will give examples of practical solutions tried and tested on compared results of different design solutions from Europe. After this block of presentations, we'll have time for your questions. So please add them to the chat or raise your hand and I will pick you and ask you to introduce yourself and ask your question. At the end of the seminar, Erkki Verkasalo will say the closing words. And with that, I want to hand over to Pekka Leskinen. While Pekka and Rick are starting their presentation, let me introduce both of them. Pekka Leskinen from the European Forest Institute is the head of the Bioeconomy unit, but that also my supervisor. Hello, Pekka. And he is a professor of forestry. Pekka has been leading work on advancing the knowledge on the circular bio-based economy, especially for wood and the wood sector. That includes also bioeconomy markets, the circular use of timber, and of course with that also substitution potentials. From Bonn, Germany, I'm very happy to welcome Erkki Verkasalo, who will continue his presentation. He is the team leader for the urban forestry team of FE Bonn of the resilient programs. He's coordinating the EU program on the Senior European Research Project on Clearinghouse, from which he will give some results, where he will look at how to apply urban forests and timber in an urban setting. So based on the experience that he has, like how you can include nature and buildings for more positive impact of trees to the urban climate. Without much further ado, Pekka, please get started.
Thank you, Diana. First two questions. Can you see me? Can you hear me? And actually third question, can you see my PowerPoint first slide?
I can see you. I cannot see your PowerPoint.
You cannot see my PowerPoints.
No.
Really? Just a minute.
Sorry, I think that was me. Try again. Now I can see your screen.
Okay. Yeah, then try once more.
No, it's fine. I can see it now.
Okay, just a minute. I will put that in the full presentation mode. So can you, once more, can you see my PowerPoint presentation?
I can.
Yes.
Okay, thank you. Now we can start. So thanks a lot for the introduction, Diana, and chairing this session. So as Diana mentioned, this will be a joint presentation between Erkki Vreese and me, and I will start taking some issues linked to climate and wood construction, and then Erkki will follow me on topics linked to urban planning and how wood construction could be important in that frame. And then to start from the beginning, start from the climate challenge, then the climate challenge, climate change is maybe one of the most important reasons that why we talk today so much on topics linked to emissions of the construction sector, and in that frame also on wood construction. So basically, if we take into account the global emissions, we are at the magnitude of 50 gigatons per year currently, and if we want to achieve the 1.5 degree target, then by 2050 we should be at the magnitude of 5 gigatons emissions per year, so only about 10% of the current emissions. And now this is of course enormous challenge. We really have to act quickly, otherwise we will lose the control of these processes. And then of course all possible issues should be done, and wood construction can play a role in this context. Of course, not the only solution, but can contribute. So this is the background. Then if we think a bit more generally, what really is the role of the forest sector in this climate topic? Actually, the role of the forest sector is on the other hand quite simple. On the other hand, it is a little bit more complicated to have the full picture. In this illustration, we can see on the left-hand side the fact that if we have forests grow, they will establish a carbon sink. But on the other hand, if we harvest forest biomass and use that for construction purposes, actually then also in the technosystem, so-called technosystem, we can achieve climate benefits as well. And what makes this issue pretty complicated to understand is that actually what matters from the viewpoint of climate is that we shouldn't not focus only on the left-hand side of the illustration or only on the right-hand side of the illustration, but this big picture should be taken into account simultaneously if we want to maximize the benefits that the forest sector can do for climate change mitigation. And it is easy to say, but there are many linked issues that it seems that it's quite difficult to communicate and discuss and make reasonable decision in this frame. And one of the issue that I feel, and many of my colleagues think, that the right-hand side of the previous illustration is not that well understood than is the left-hand side of the illustration, how forest ecosystems behave. And that's why some time ago we made a study on substitution effects of wood-based products in climate change mitigation. And this was a review synthesis study that the aim was to kind of update the recent scientific understanding that what these substitution benefits actually are and how these type of emission reductions achievable in the technosystem, how those actually should be taken into account in the decision making, as I was referring to into some level of the complexity to cope the topic at full scale, kind of a holistic approach in decision making. And since we have only a short time slot for give the presentation, I will go directly to the results without any further explanations. And this is a summary table of the results that we achieved by the review study. We calculated average mitigation benefits, achievable mitigation benefits for several product categories. Those were structural construction, non-structural construction, textiles, and other product categories. And if we now consider the structural construction side, and if we assume that we use 1 kilogram of wood to this type of production purposes, structural construction, I mean, and if by this action we replace concrete and steel in the construction processes, then we can achieve on average 2.4 kilogram of CO2 avoided emissions on average. Of course, there's a variability, some uncertainties linked to this average number, but this is what scientific evidence currently says. So 1 kilogram of wood means 2.4 kilograms of avoided CO2 emissions. If we use the kilogram of wood to non-structural construction like doors and window frames and so on, then we would achieve on average 2.9 kilograms of avoided CO2 emission reductions. If we use the kilogram of wood or forest biomass to textiles productions, then the numbers can be even bigger. But in any case, there is a clear evidence that in the technosystem, wood construction is clearly beneficial in terms of climate change mitigation. And this is of course important for the wood construction sector and our climate challenge, as I mentioned. But then, on the other hand, if we have good, let's say, product level substitution benefits, that is as such not enough. We also need to have big market volumes if we want to achieve something that climate will recognize. Now, if we consider the textile production dissolving pulp, we know that the product level substitution factors are very beneficial, but at the same time, currently, the market volumes are not yet there. But we have many good reasons to believe that this pillar here will be much larger in the future due to increase in market volumes. In packaging and paper industry, we have the market volumes, but on the other hand, we have actually quite much lack of knowledge because of large variety of packaging materials. We really don't know that what could be the average substitution impact on packaging materials. We need more studies here. Then if we consider printing and writing paper side, we have the market volumes, but actually here the substitution could be on the other way around because of electronic possibilities to read newspapers, for example. But again, in construction related materials, sawn wood production, for example, we have the market volumes and we have relatively high product level or intermediate product level substitution factors. So we can say quite safely that the wood construction contributes already quite significantly in climate change mitigation. So these were the results, and then if I'd like to take some take-home messages on the wood construction side before Rick will continue on urban planning issues. So just to repeat, we can say that almost always when using wood or wood-based products instead of non-wood-based products, it is associated with lower fossil and process-based emissions. So this seems to be clear evidence. We can produce some average numbers, but on the other hand, this type of substitution calculations are important, but they are not sufficient to make decision or guide policy decision making. As I mentioned earlier, we need a holistic approach that takes into account the full picture. The left-hand side of the equation on forest ecosystems and the right-hand side of the equation on technosystems. So both of these should be taken into account simultaneously. And then finally, even if we are using wood as a construction material, even in that case, it's really important to try to do something better in the future than we can do currently. We need more research efficient production processes. We need to minimize the material waste. And this is something that this wood construction related industry should keep in mind as well. And we need to do something better in the future than we can contribute today. Then in many significant potential future areas, we have actually quite much lack of knowledge on climate impacts on emerging wood, forest or wood-based products in the textile industry. We need more studies. Packaging industry, especially also chemical industry, is a really wide topic, and we need much more new studies. In this frame, although there of course are knowledge gap when it comes to mitigation impacts of wood construction, I would say that perhaps that is still maybe the best known area in this bigger. So that is of course positive side for the wood construction. And then finally, you know, the famous illustration and the sustainable development goals. Then I think that when it comes to the role of the forest sector, maybe the one most important, or one of the most important objective is the responsible consumption and production, because if we can downgrade the emissions from the side of the production processes, then we can still keep the economic activities up, and at the same time we can do some benefits for the climate. So in this sense we can achieve win-win solutions instead of trade-offs, and those usually are much more easier to be implemented in political decision making. So this was my part of the presentation, and now Rick, I hope that you are online.
Thank you, Pekka. I hope you can hear me well. Greeting from Belgium. So where Pekka has been looking at the wood after it has been harvested, I will start from the tree as a living thing still. So before we harvest the wood, and trees, especially in urban environments, also can have a quite important impact on the climate, the urban climate, mainly local climate. Of course, we all know that trees sequester carbon, and it's not only the large forests like you have in Finland or in other countries which are really sequestering the carbon, but also urban forests, the trees in around cities and towns can sequester quite a lot of carbon, and the University College of London has been doing research which has shown that the total carbon sequestration in urban forests and urban trees is equal to the carbon sequestered by tropical forests. So this is from a climate perspective, this is some source, some carbon sink which is still undervalued and underestimated, I think. Another impact of urban forests and urban trees on sustainable on urban climates, but also on reducing carbon emissions, is by the cooling effect and the shading effects of urban forests and trees. We probably all know the urban heat island effect, as illustrated on the right-hand side of the slide. cities and towns without trees and without vegetation in general have a higher nightly temperature during, overall of course, but this is more important during heat waves. The difference can go between 5 and 7 or even higher the number of degrees if you compare the night temperature in a city with the night temperature, let's say, in the rural countryside, 20, 30 kilometers out of the city. And for the human comfort, it's particularly this night temperature which is very important. We had a heat wave this summer in Europe. It has been a bit under the radar because of the COVID pandemic, of course, but the numbers were also, again, very, very high, with lots of additional people dying due to the heat wave. So this is one of the important aspects where urban forest and trees can contribute to. It's not only the thermal comfort for humans, but it also has a also high impact on the use of air conditioning. If temperatures in the cities are lower, then of course the use of air conditioning is much lower. On the other end of the spectrum, urban forests and urban trees can also limit cold winds and can also have a good impact or an interesting impact during the heating season, limiting the use of gas or electricity or other sources for heating. So this is already 2 points or 2 aspects where urban forests and urban trees can reduce carbon emissions, not directly by sequestering the carbon, but by creating a better climate. We all know, of course, also that trees have a positive impact on the soil and on water when we have high rains and so on. But one important aspect also, which is an indirect contribution of forests and trees to carbon emissions, is that they create a nicer environment where people will more easily take a bike or go by foot to their work instead of taking the car or public transport. So next slide, please. Pekka, I think you are on the controls. Can we have the next slides?
I'm trying to change.
Now, I will continue my story in the meantime. So, well, as you see here, and as already introduced, the benefits of trees, the co-benefits of trees, urban trees and urban forests go beyond carbon and climate. There's also an impact on, as I said, creating a nice environment, which will lead to not only to a shift in the use of transport systems, but to healthier people. The impact of urban forests and trees on the public health is really still underestimated. And in a country like Belgium, a very populated country, there have been calculations that indicate that the economic value of trees, urban trees, forests, urban and rural forests, is higher when we are looking at the public health expenses, at avoided public health expenses, than when we are looking to the value of trees based on wood values. So this is, of course, something interesting to keep in mind when we are planning our cities and towns. In the next slide, we can see one quite nice, but also very experimentary example, the Bosco Verticale, the vertical forest in the city of Milan. And of course, this is a real flagship project, but it illustrates very nicely what we can achieve with building with trees and building with wood or building with nature in the cities. Every year, the trees and the shrubs on the towers, there are 2 towers, avoid or absorb 30 tons carbon, CO2, and they produce 20 tons, 19 tons of oxygen. As I already introduced, the energy consumption both for air conditioning and for heating the building are lower. It's 1/3, which 1/3 gain we have there, and it contributes to a decrease of 2 degrees Celsius for the urban heat island effect. Well, this seems to be not very high, but it is important. Every degree we can avoid in the heat island leads to saving human lives. Also for the biodiversity, well, it's a calculation, it's an assessment. I don't think there are already counts done, but the expectation was there would be 20 more bird species present around the building and 50 or 59 more plant species than if this would have been a traditional concrete tower. And I've also introduced the healthcare impact. Very unfortunately, this tower is built with concrete and steel. And on the other side of the medal, of course, on the side of the coin, this green all needs, these trees all need support. So there is an additional expenditure for additional concrete, additional steel, and also additional irrigating systems. However, according to calculations by the architects, which are area architects in Italy, these additional expenses are outweighed very much by the benefits the vertical forest, the Bosco Verticale, is creating in the urban ecosystem. This brings me in the next slide to the concept of integrative planning in cities and landscape planning. The Bosco Verticale illustrates that integration of landscape planning and cities planning can contribute to compiling and shared goals in respect of sustainable development. It's not only the building guidance who has to put forward the need of building with wood, but also landscape architects, city planners, and so on should share the same goal. And well, in the looking at trees and woods, it's a nice story, maybe, if you like, that you can start from a single tree, which is at the moment growing next to the building, but also it can lead to a new wooden building in the future. As I said, it's a transdisciplinary approach, which brings professions from different sectors and different professions together to solve common problems, which are dealing with public landscape and public. Although, of course, lots of the forests are private, forests are still seen as public owned. There are lots of opinions on forests. I don't have to tell this to this audience, I think, but also buildings like the Bosco Verticale also create some common language, common experience for the cities. So it's and the example you see in the picture here is an example from the old industrial sites in the Ruhr area in Germany, in one of the case studies of our clearinghouse project, where trees are taking over the old industrial coal mines and old industrial heavy industries, which is a very nice example of what you can achieve with integrative planning, building a public park, but also keeping the industrial heritage intact. Integrative planning also helps to deliver projects that occur over a long period of time. Buildings nowadays, especially non-residential buildings, are built for a lifetime of about 30 to 50 years. Of course, when we are working with trees, we are looking at lifetimes that are 50 to 100 to 200 years. So by an integrative planning, landscape planning, we can also, and we have also to look over a longer time. And when we're looking over longer times, we are impacting several generations. And we all know the saying, if the father is planting a tree for his son and grandson, and only the grandson will see the tree in its full wisdom. The next slide is looking how it's also an issue or an example of Milano, the city of Milano, where we initially had this the picture of Bosco Verticale, but the Bosco Verticale is part of a much more larger plan to create a green river and a green urban forest for the city of Milano, connecting all different districts through a green ring along the motorway. But also you see the connections to the surrounding landscape, to the surrounding mountains, but also the surrounding forests. So we start in integrative planning, you start looking for a very broad, very wide perspective, the surrounding landscape, and this ultimately leads to creative visions and integrative visions for the individual building, like the Bosco Verticale. Next slide, please. So integrative planning starts from creating multiple benefits for, well, in the case of the Bosco Verticale, for new residents, but also for the communities who are already there. And we all know that there's a lot of movements in our cities. People come in, people go out, new communities come on, old communities sometimes feel pressure from new communities. But if you work from an integrative planning perspective, you do not only create a new building, but also you can also create a new environment which is also attractive to other peoples. And by building things like the Bosco Verticale, which is integrating a lot of green in the landscape, in the urban landscape, we also provide some additional benefits for people who are already living in the area. So we can promote the use of wood and wood-based materials as substitutes, like Pekka introduced, but in the same time, we also can integrate some new tree planting. And also there, for planners and politicians, for instance, this can be a very nice story where you can indicate, well, look for this building or this new industrial area, this new residential area or industrial area. We had to cut, let's say, 500 trees, but look, we will be planting 5,000 trees. So we are really substituting what we took out of the forest by new trees and new urban forests. And by this way, we are developing a green infrastructure corridor that can also offer sustainable transport like walking and biking, will also have an important impact on the public health and well-being by designing new areas. Diana already introduced the clearinghouse project we are working on, and on the picture you see below, that's the city of Guangzhou, one of our case studies in China. China has a very interesting national forest city program. They have now about 200 cities being awarded the national forest city label, or the forest city label. And this award is the result of a very integrative planning, urban planning, but also monitoring and assessment process, which takes 10 to 15 years. Of course, China is, well, when it comes to planning, it's a very nice example how you can achieve things with the longer term planning, 10, 15, 20 years. And how within our within the clearinghouse project, we are looking what we can learn in Europe from this Chinese National Forest City program. The next slide, just briefly touching upon the clearinghouse project, which is a project I'm coordinating with 26 other partners, or 25 other partners, both from Europe and China, and we are exactly looking in how we can use urban forests as nature-based solutions for creating a more sustainable urban environment. I'm will not talk a bit more on the project because time is limited, but I do invite you to take a look at the website and our social media channels to follow what we are doing and will be doing in the next 3 years. So this brings me to my key messages. And well, the first message is reiterating what Pekka said. Wood substitution is not sufficient. We need a holistic approach, and the holistic approach should go beyond the individual building, should go beyond the individual tree, or should also go beyond the selection of or the decision to build with wood. We should look how we can include trees, urban trees, in the urban environment. One of the challenges is, of course, I didn't touch upon this, but one of the challenges is to conserve existing trees and forests in cities and towns when we are redeveloping or developing cities further, but also how we can use building and urban planning to increase the tree cover, both at the city, street, and block level. And while building on what Pekka said, we should also integrate the use of wood-based building materials in building directives. And finally, I would like to close with the picture on the right. This is a mobile equipment to solve trees, to solve urban trees, which at the moment are still and a lot of time not used for construction or for sustainable use. But this local tree, the local street tree in your own street can be used to make nice furniture in the park, like benches and picnic tables and so on. So there's another challenge there, and which can be maybe an idea for the next conference, how to use the trees in the urban forest and the trees in the urban environment to create sustainable environments. Thank you, Diana.
Thank you very much to Rick and to Pekka for this introduction on a more outreach and outside of the construction and more everything around. With that, I would like to lead over to Matti Kuittinen. Matti is an architect with a passion for resource efficient and sustainable construction, and he has been working on improving building performance in different roles, such as a professor at Aalto University, but also as a senior advisor at the Ministry of Environment of Finland. In the latter function, he has been fundamental in advancing a method for assessing low-carbon construction for Finland. And I'm curious with a presentation today, which is about carbon footprints and handprints, searching for the balance in the built environment. Matti, the floor is yours, and please feel free to share your slides.
Thank you very much, Diana, and good afternoon, everybody. In a moment, I will share my screen and you should be able to see my presentation. There it goes. So today I'll be talking about carbon footprints and handprints and how should we and how could we find some sort of balance in the built environment. And I'll start from, let's see, I get it working, from the quest that we have ahead of us. It's the thing is that we should urgently decouple from each other the value and quality of the built environment and the consequential environmental and social harms that is caused throughout the full life cycle of the built environment. This is a significant challenge for all of us, and I'd like to say from the beginning that we should not build anymore and think that okay, we will solve the crisis by doing the same amounts of operations in a different way, but we should also critically review the needs for all new operations, including construction operations. So the reason for this is rather simple. We at the moment consume half of global raw materials for construction, and in the near future, as the population grows towards 11 billion, as the infrastructure ages, and as the sea levels are steadily rising due to the most likely collapse of the Greenland glaciers, there will be significant needs for new construction, or let's say significant needs for new spaces for different functions and relocating the existing spaces and infrastructure. And if we take a look at the climate budget side of this equation, according to IPCC, at the moment we have around 560 gigatons of CO2 available within the carbon budget if we want to keep the global warming within 1.5 degrees. Now, if we continue to produce construction materials, such as cement, steel, aluminum and plastic, with the current consumption rate and current technologies, we're going to almost double the amount of emissions that we could allow to emit if we want to keep the global warming in the preferred range. So that's rather serious, and this is just between now and the year 2050, so in 30 years. If we could, however, switch into production technologies that are very energy efficient, and if our factories could run on renewable energy, then possibly we could push this figure down to a nicer looking number of 550 gigatons. But that's still almost the entire global carbon budget, so it's still too much. And it's been estimated by, or there's actually a meta study of recent processes and recent innovations, and it's been estimated that with these new radical measures of circular economy, we could possibly push this figure down to 300 gigatons. But that requires rapid scaling of the lab scale technologies that are still in the lab. So that's also challenging, but this appears to be the only way to go if we truly want to keep with the Paris Agreement's goals. So that's why the decoupling is important. Now, if we look at the Finnish case, we have good statistics, or relatively good statistics, about our emissions and sinks over the years, and then we have political goals of reaching carbon neutrality and carbon negativity. So we need to go down with their emissions and maintain the sinks, and hopefully by year 35, so in 15 years, these are in balance and we have found carbon neutrality. And as you know, the quest doesn't stop there, but we are aiming towards carbon negativity in 2040s. And I feel and I consider it important to consider that how can we also increase those sinks within the built environment, as the previous speaker was talking about. So that might become an important issue, especially when it may be rather difficult for our agricultural sector to cut their emissions in the required scale. Now, this is why I said in the beginning that we need to reconsider the needs for new construction. Do we really need to build so much new buildings? If we look at the population trends in Finland, it looks rather flat. Of course, we understand that the infrastructure is aging, but I think that this requires some consideration of thoughts that may first feel a bit unpleasant. Because I'm an architect, I've been thinking about how these should be translated into design guidance and priorities. And I feel that we should reconsider the priorities for construction like this. I think that the most preferred option always should be to utilize already existing spaces that don't need modification, but just need agreement on the share of those spaces. That way we could have a much better use of the existing invested resources in the built environment. Then the second best option would be to renovate an existing building so that it fits to the required needs. Third best option would be to do an overall refurbishment of the building. And actually, when we look from the resource efficiency and carbon efficiency viewpoint, building a new one could be considered as the last option. Of course, this is rather narrow-mindedly looking only from the viewpoint of resource efficiency and climate impacts. There are other reasons that may well justify building new buildings, such as health or safety and so forth. But if we just consider the use of resources, this is how it could look like. This could be the priority for construction. Then if we think that how can we, if we choose to build a new building, what are the means of doing the new building in a most climate and carbon efficient manner? I could present like a strategy that looks like this. We could consider three different aspects. We should consider the premise for building, then sufficiency and efficiency. Normally we only talk about efficiency, but I think that we have perhaps unintentionally left aside the questions of premise and sufficiency. What do I mean by these three viewpoints? The premise means asking these rather difficult questions already in the beginning of the project. Do we really need to build? Couldn't we use space as a service? Or if we end up building something, what is the most efficient or most optimal building type for our needs? And how could we share those resources that we are developing and creating while we are building? Then, if we just consider the premise without changing sufficiency or efficiency, we are already better off. The next point where we can make a change is consider sufficiency. How much floor area, how much volume do we need for the building? Can we do the design in a manner that really serves the functions and serves the needs of the users and still use less area and volume? And again, how can we share the space? And if we do these interventions of sufficiency, even if we wouldn't change the premise or the efficiency, we would again be better off towards a low carbon building. Then finally, the efficiency is what we normally talk about when we talk about energy efficient or low carbon building. We consider the efficient use of space, energy efficiency and material efficiency. And these are of course important, But I argue that we shouldn't start from the efficiency without first thinking about the premise and the sufficiency. And in the ideal case, if we can make improvements in all of these areas, the added impact would be even better. So then a few words about policies. As many of you know, we are planning new building regulations, and one of the things would be limit values for different building types in terms of their carbon dioxide equivalents. The title of my presentation was about handprints and footprints, and here is where that concept comes in. Now, the emissions on the right-hand side, they are normally when we talk, we describe them as footprints, something negative that happens. But I think that we should start to consider also the handprint side, which is normally understood as some positive impact that wouldn't happen without the project that we are taking. And that's why we are in the regulation, we are planning also for setting initiatives and incentives for increasing carbon storages in the building stock. So both sides should be in balance, ideally, but it's of course extremely difficult to reach a total balance without compensations. This is how the forthcoming policies would look like in Finland over the life cycle of a building. If we look at the typical life cycle of the building, that starts from the design, then we have the production phase, then the construction phase, use phase, and end of life phase. Well, here in the design phase, we are planning to set mandatory material declarations for buildings, also mandatory climate declarations, through which we could observe that the building stays within certain given carbon footprint limits. And this would happen before year 25. And then in the design phase, we would also require a mandatory building information model through which all of this information actually could be retrieved. And that's the ideal goal. Then at the construction stage, before the building is taken into use, this information would have to be updated into so-called as-built status so that we can really see what materials ended up in the building. And finally, when we do refurbishment or even demolish the building, we are looking towards digitalization of so-called pre-demolition audits that let us to gather better understanding about all the material flows that are associated with the built environment. And indeed, the built environment is a huge repository of different materials. Some of them are useful, some of them are harmful. And we have started to approach this material flow or metabolism through the lens of carbon, because it is a critical asset within the next decades if we truly want to save the planet from a climate crisis. And as we well know, we have a tremendous potential in the forest if we really keep the forests as a carbon sink and utilize the materials in the most optimal manner. And the interesting question is that how could we improve the potential of buildings for storing carbon and for having a better substitution potential between different solutions. And for figuring this out, actually, I had a study with my colleagues at Germany, and we were looking at all possible ways of storing carbon into buildings. We could identify 13 different approaches. Of course, the most common ones are bio-based materials and composites. This is self-evident for all of us. But then the role of plants and the photosynthesis, this seems to be something that we could enhance. And one way of looking at this is to also take into account the soil organic carbon. And how can we really, in a better and in a more conscious and controlled manner, accumulate carbon into soils? And interestingly, also in the urban environment, this seems to be a really good potential. And in some cases, this urban soils can even accumulate more carbon than natural soils, which is, of course, at least it was to me, counterintuitive, but there is strong scientific evidence for that. One way of boosting that is to use enhanced weathering, in which we put some minerals like olivine, stone, powder, or similar minerals that weather into the soil and thus boost the carbonization in soil. But also biochar in the growing mediums, but also within certain products such as asphalt or concrete. can increase the carbon storages in the built environment. Then, of course, we have the carbonation of cement-based products that could be utilized to a greater potential, especially if we can utilize the rubble, concrete rubble in some landscape works in which it can be in contact with air, in which case it carbonates faster. Then we have some sci-fi or high-end solutions like direct air capture of CO2, which seems to be rather potential in the future if this can be plugged into the ventilation machines of buildings. But examples of artificial photosynthesis at the moment seem to be rather far off in the future, so they don't seem to bring us required emission reductions anytime near soon. If we can get carbon capture and storage working in a nice manner, then we could potentially manufacture plastics from carbon dioxide that's off from industrial processes, and also cure concrete with carbon dioxide, in which the carbon storage, in this case the carbon storage, would be a permanent one. So with this illustration, I just mean to show that we have promising technologies already now. We have some technologies that may be available tomorrow, and then we have some technologies that are in the horizon, but in a very, very long time frame may be applicable. So we should take use of the existing methods and in a consistent manner apply these to building design. So this is where we started, the 50% consumption of materials. And question for us is that how much of the materials that we use for construction could be used in a manner that we also turn the built environment into a carbon bank? Thanks for your attention.
Thanks a lot, Matti, for your presentation. It was very fascinating. Thanks for keeping the time. You're a bit ahead of time. So as the questions come later, if you have some, please add them to the chat, and also mention your name, your organization, the question, and to whom, and we'll pick them up later. Without much further ado, I suggest we change over to Satu Turula. Satu Turula is a project coordinator at the Urban Environment Division of the City of Helsinki. My bad. With an environmental background and a strong societal emphasis, she has been working to develop and speed up the circular bioeconomy approach of the city of Helsinki, as well as to help Finland's biggest companies to achieve their sustainability targets. For the past 2 years, she has been working to help the city of Helsinki to achieve its goals of carbon neutrality by 2035. So this includes tackling the climate effect of procurements, on which we'll elaborate in her following presentations, actions to promote low carbon procurement in city level. Satu, the floor is yours. I think you're muted. You need to unmute. You're still muted?
Yes, no. Very, very classic. Sorry about that. Can you see my full screen now?
I can.
Okay, great. Excellent. So thank you very much for this great introduction. It was super. Good afternoon on my behalf as well to everyone. My name is Satu Turula and I come from the city of Helsinki. And actually, I currently work as environmental planner in Urban Environment Division. I just changed my job, so that's why. So at the moment, I work with environmental management and also sustainable procurement. And my main work at the moment is to help our city divisions to procure sustainably. So that's why basically I'm here today. And of course, in this role, I'm involved with a mix of very diverse procurements. But today we are talking about construction and buildings. And I wanted to give you today a quick overview of the most central strategies that we have at the moment concerning the topic of low carbon procurements within construction. And then I would love to move on to some recent case examples that we have currently going on in Helsinki. Yes, there you go. Okay, so the city of Helsinki is one of Finland's biggest buyers. We procure by 2.5 billion euros each year. And with this said, I can say that we really have the power to promote sustainable and low carbon procurements. And I would say that we are finally beginning to do so in a great extent. In Helsinki, we have 5 different procurement units, and 4 which are the city divisions, and 1 is our central procurement unit. And all these 5 procurement units, they make their procurements very independently. And of course, the urban division is the biggest procurer in Helsinki, and we also have the biggest climate impact, as we do a lot of infrastructure and building construction and refurbishment and maintenance work. So that's why this is also very interesting. Okay, so at the moment, I am very, very pleased to be able to tell you that we are not running out of plans or roadmaps in Helsinki. And we are very, very committed to creating low carbon and sustainable city. And our strategies fully support that goal as well. So our current city strategy, that is from 2017, highlights the importance of modern climate responsibility. And our carbon neutral Helsinki action plan is from 2018, and it shows us the way of how to create carbon neutral Helsinki by 2035. And our latest citywide sustainability action plan is the roadmap for circular and sharing economy. And this was launched this May. So it's very, very new still, and it is aiming towards circular loops in four focus areas, of which one is of course construction. So the ambition is clearly there, as you can see, but what about the actions then? Well, the Carbon Neutral Helsinki Action Plan strongly guides the development of the construction in Helsinki today. And here we can see some actions from the Carbon Neutral Helsinki Action Plan. There are actions from all stages of construction, from planning and plot reservation conditions to building projects and to construction sites. And there are few examples of how we tighten the plot reservation rules. And then there are actions to develop new criteria to take better into account the carbon footprint and climate. And there is also one action to develop emissions-free construction site in here. And in case of circular economy, the actions can look like this, for example. So these are from the circular economy roadmap that we just had. So naturally, it is so great that we have this many action plans and roadmaps going on. But at the same time, it is obvious that plans do not reduce the carbon footprint of the city by themselves, but we need actions. And we can say that we now have the goals in order, but how do we do these ways of working become business as usual is the key question, I would say. And in Helsinki, as in many other cities, I'm pretty sure the strategies are drained to the construction through forms of various guidelines and projects. And I will use the time that I have left to introduce you to 4 recent and hopefully interesting examples from the built environment. Some of these are like more experimental projects, and some are more business as usual. But if we start from plot conveyance terms, so here is Kalasatama, this is Kalasatama is one of the largest new areas being built in Helsinki at the moment, and its construction started in 2009, and it is planned to last until the late 2030s. This is a former port area, an industrial area, and it's about to host a home for 25,000 residents in the future. And here in the picture, you can see the construction schedules for the sub-areas in Kalasatama. And Kalasatama is also a smart city district of Helsinki. So it is being developed flexibly and through experimentation and together with residents, companies, the city, and other actors as well. And that's basically why we chose this area. We are so we have this upcoming plot reservation competition coming in exactly in Kalasatama, and we are aiming to test very ambitious environmental criteria in one of the upcoming plot reservation competitions this autumn still. And this competition, it aims to improve the stormwater management, resident comfort, energy efficiency, also increase the use of renewable energy, of course, and reduce the carbon footprint. And also I can share at this point that the city's plot reservation conditions were tightened in 2019. So we have at the moment the most or the strictest ones in Finland, and we are aiming the A energy efficiency level in all our quality and price competitions at the moment. But what is interesting in this case is that we have considered E number, green factor, and carbon footprint to have a significant even determinative emphasis in this competition. And we really hope that by doing this, we will achieve very ambitious plans for this plot. And we will see in the nearest future how it goes. Okay, so then if we move on to design phase, so what happens in the design phase then? Well, I will explain at this point that the city of Helsinki runs roughly two kinds of building projects or design projects, and the so-called traditional projects where we first choose the designer and then we choose separately the contractor. And the client, so the city is leading the design phase. And then we have these design and build projects where you choose one contractor who both designs and builds the project. And let's take first a look at the design, this first scenario, sorry, and then see what happens there. So, to make sure that we design and build ambitious municipal buildings, we have developed in Helsinki this life cycle management model to set and monitor this project-specific environmental targets throughout the project. And this is very interesting because it sort of brings together like all the most important life cycle requirements of the city's various guidelines and goals and those strategies that I just shared with you. So these are the like the starting point for the design. And the objectives are set in the planning phase. And life cycle requirements, they are related to, for example, life cycle carbon footprint and costing and stormwater management, landscaping, resource-wise construction, energy efficiency, of course, renewable energy, and so on. And here you can see in this picture the 9 objectives, and they are reviewed in every single project. And for example, if I give you an example from energy, the geothermal heating is always #1 heating option if it's possible to utilize. So this is how you make sure that you go through all these 9 goals when you are in a planning phase. And this is also something that we still develop. It is mandatory in all our projects to go through this, but the life cycle requirements, of course, we add them as they come and as we see that they are needed. And the requirements are monitored from design to construction, commissioning of the building, and at the end of the warranty period as well. Then I have one interesting case from design and build contracts. This is actually a case that was conducted during Kanemura project that I was before coordinating. And this is a project that you should definitely check out if you're interested about low carbon procurements in city level. And here you can see the Kanemura webpage as well if you're interested. But here we wanted to procure 4 wooden apartment buildings, which are located in Kuninkaantammi, and Kuninkaantammi is one of the newest residential areas in Helsinki, and it is also an area where solutions related to climate change adaptation and mitigation have been developed and piloted for years already. So that's why we felt that this could be a suitable area for testing this. So in here, we wanted to guide the designing of buildings towards low carbon, as well as to achieve low carbon solutions. And why we did this, of course, because as the energy efficiency of new buildings is constantly rising, we feel that, or we know that we need to start targeting the carbon footprint of the construction and the construction materials as well. And in this pilot, we wanted to test a new method to reduce the carbon footprint of the buildings in design phase. Then how did we then do it? So the new approach here was that tenderers needed to calculate the carbon footprint of their plan or the design. And then the result was scored as part of the tender. So it was quite new and interesting. And the carbon footprint was calculated using the low carbon assessment method for buildings by Ministry of the Environment, and this guaranteed their comparable offers as well. Of course, we wanted to give the climate criteria proper weight in this procurement, but at the end we needed to compromise as always. So the quality had 50% weight and the price had 50%, and of the quality, the environmental criteria had 20% of the weight. Of course, in addition to award criteria, we also had minimum requirements to make sure that we have ambitious enough solution. So, for example, the E number needed to be lower than 75. And well, what was the outcome then? So we received 2 offers. Which I think it's quite normal, knowing that the market for the wooden buildings, because sorry, I forgot to mention that we had the obligation for wood construction here. So the market for the wooden building contractors is still quite limited in Finland. But what was good news is that both of the tenderers were able to calculate the carbon footprint for their tender, and they were there was a quite significant difference between the carbon footprints also because of the heating method they selected. what was unfortunate was that in the end we ended up in negotiation procedure, and in the beginning of the procedure, unfortunately, the other tenderer gave up the race, and it was unfortunate that the one who gave up the race was the more ambitious one in terms of carbon footprint and E-number. Thanks to our minimum requirements, we still received like okay level in ambition, but it wasn't what we were hoping for, of course. So after all, I can say that the framework used here still requires practice and fine-tuning in terms of scoring the carbon footprint, for example, but it could be used in some of our projects in the future as well. Okay, and lastly, still have a few minutes. Let's take a look at our construction sites and what we're doing there. So the Ministry of the Environment, Senate properties, and a few cities, cities of Espoo, Helsinki, and Vantaa, and also Turku, we signed a voluntary Green Deal agreement to reduce emissions and at our construction sites on September this year. So this is also very fresh. The Green Deal is, or the Finnish Public Procurement Green Deal is a voluntary agreement between the government and the procuring authority. And the aim of this Green Deal is to create a gradual path forward for zero emission construction sites by 2030. And in the background, why did we do this? Of course, is the fact that emissions from work machines also account for a significant share of urban and municipality climate emissions. And there are also hazardous emissions or emissions that are hazardous for health that we want to reduce. So that is why we took part to the Green Deal. Some of the key milestones during the process of City of Helsinki are presented here. So Helsinki actually has long promoted the development of emission-free construction sites through various projects, and we have been actively cooperating and taking part to international projects as well. And we have been involved in the Green Deal negotiations since the very beginning. So we have started implementing the Green Deal on infrastructure contracts now. So we launched our first pilots of low emissions construction sites already this spring. And we made the decision that all our new infrastructure sites will be fossil-free and low emission from this spring onwards already. So in practice, this means that they can only use fossil-free fuels, such as biofuels, and the machinery used needs to fulfill the criteria of minimum stage 4 and the heavy transport on site, the minimum of Euro 5 classification. And then the next challenge for us is to expand the pilots to our house building and maintenance project as well. But this is something that is by default from now onwards on our infrastructure contracts, and I think this is although the emissions from construction sites are not that big, I think this is still very important, and it has received very good good feedback from the construction industry. Okay, thank you. I think this was my presentation, and I thank you very much for your time and listening.
Thanks a lot for this very interesting presentation, Satu. It's quite fascinating to see some real examples from the city. How can you really translate different plans and ideas at the city level.
Yeah.
We will continue with practical examples, and with this I want to invite Mikko and Mika to give their shared presentation. Mikko Matveinen is project manager at the University of Applied Sciences, and Mika Keskisalo is project specialist at the same institute. Both of them are among the main organizers of the Drivers for Wood Construction seminar, and with that also of this webinar session. And they also have been actively involved in engineering or assessing some of the leading wood construction buildings here in Joensuu, such as the Lighthouse, which serves as student housing. And building on some of those practical experiences, they will shed a light on different design solutions and the practical performance with regards to low carbon construction in apartment buildings. Mikko, the floor is yours.
Thank you, Diana, for the introduction. So this presentation is about we'll show you some results and findings of our project called Towards Low Carbon Construction, Joensuu Wood City. And my part is I'm gonna show you some examples what we have been doing during this project, and after that Mika will show you some tangible design examples. So first few words about our organization, Karelia University of Applied Sciences. So we are located in the eastern part of Finland in Joensuu, and in Finnish scale we are a middle-sized University of Applied Sciences. And as you probably know, so in Finland, University of Applied Sciences has also strong role in national innovation system. And therefore, our organization has selected some areas where we focus on research and development, and the wood construction has been one since 2014. And more recently, we have been widening the scope also low carbon construction in general. So some basic information about our project, which will end by the end of this year. And at this point, I want to also thank you, our financier in Finnish, Etelä-Savon ELY-keskus, for making this project and this journey possible for us. And about our project objectives, so the project has been focused on strengthening the know-how and understanding related to low carbon buildings and low carbon construction in general. And we have been working very closely with the different municipalities in North Karelia in order to increase their knowledge as well. And during the project, we have been carried out life cycle assessments for the different kind of building project, and those projects and assessments has been worked as a pilot cases for our activities. We have been also doing some concept design for the low carbon city block, and we have been focusing especially the product stage phase in this case, and about this Mika will tell some examples later on. I want to shortly show some activities what we have been doing here in the project. So big part has been focusing to knowledge transfer related to low carbon buildings, and related to that we have been arranging different kind of seminars and workshops to increase the knowledge also within the stakeholders. We have been arranging study trips and benchmarked others, what the others are doing in Europe related to this topic. And this example is from Austria. Last autumn we arranged a study trip for our stakeholders to Austria, and we also visit there in this 24-story high wood concrete hybrid building in Vienna. And this example also strengthened the assumption that if you want to build low carbon buildings, we very often have to be ready to combine different materials to achieve the best possible results. Here are some buildings listed. For these buildings, we made the life cycle assessments, and these assessments has been worked as a pilot cases. And half of these, or 3 of these buildings, has been made out of timber, or in this case, massive wood, and half of those have been made out of concrete. And here you can see some results based on these assessments. It has been also nice during this survey study to compare different assessment methods for the emissions. In this case, we used Finnish Ministry of the Environment method as well as EU levels assessment method. We have been also doing some studies related to specific building parts. For instance, in this case, we made a study related to wood and concrete ceilings to be used in a real school building project. And surprisingly, when you need long spans for the ceilings and very thin, you want to have a thin structure. So timber and concrete, there was no big difference between those. But of course, like Pekka Leskinen said in his presentation, that there are other good things also when we are using wood materials. And if someone is interested to read the full article based on this survey, so it can be find link below. So now the Mika will continue and show you some tangible design examples related to this project.
Okay, thank you, Mikko. I will start sharing my screen. Just a moment. There. So I'm on my own background as structural engineer. So when I'm looking at the most likely person to do these carbon footprint assessments, they're mostly architects. So it has been also a goal of our current project to show the structural engineers how you can do the assessments and if it's difficult. And some of you might know, we engineers just love these standards and design guides. So it's easy to give them these ready-made methods and guidelines they can follow. So basically you just have to follow them so you can compare the designs equally among each other. But when we look at the building life cycle as a whole, where is the most potential parts? We know that the energy consumption it's a big deal in the overall carbon footprint of the building. But now we should focus also at the product stage, where we have the potential to minimize the carbon footprint by optimizing the structures itself. And that's where we architects, structure and designers come in with the building service engineering. So we get the most efficient building footprint, what is the optimal shape, how it should be orientated. And lastly, we also can make good methods for the circular economy when we are concerning the use stage and what is the end of the life stages. What happens to building materials after demolition or when we are renovating the structures later on. But you shouldn't go like all crazy and just go optimizing every paint and varnish and flooring. You just should like get the most contributing elements. You should identify them and then start to optimizing them. And like I showed earlier, that the cutout rules stated by the standards, so we don't have to take in consideration every small connection part or nails or screws for the wood building. We can take the bigger picture with the floors that are made for structure bearing capacities and so on. So by far, I would optimize the ground floors, structure frames, especially the intermediate floors, meaning the horizontal structures, facades and roofs. So concentrating at the big areas is the key of doing it more easier. Of course, there's the foundations as well, but in Finland as well in other parts of the world, we have the minimum foundation sizes when we are using the piles for pile foundations and so on. So there's not so much potential for those to be optimized. So we have to consider the structures which are above the ground level. So those are the ones I would start optimizing and doing the work on. Also, when we are doing the transportation of the materials on the on-site, they contribute to the carbon footprint as well. But however, their share isn't so big, but we can use that to reduce the noise, improve the logistics and city air quality in general when we are taking those in concern. So we are taking a quick look of one of these blockhouses. In our project, we had this by the riverside. There's these 3 blockhouses to be built, but now they might be made out of concrete. But we concentrated at the middle one, and we shouldn't like start optimizing the whole building at once because it's time consuming, and you are not like taking the look at the things that matter. So optimizing one floor and then spreading the effect to all of them is more efficient in this way. So the original design option was done by Sweco, structure designers, and the goal was to minimize the cross sections by providing these additional load-bearing shear walls that take up the loads, which can be seen at the lower end of the slide, where in the middle, whereas these load-bearing directions and those darker lines are presenting the walls itself. But when we do this kind of design, there's not so much adaptation possibilities, so we cannot like knock down the walls or make the rooms bigger. So we have to like take in concern like what will happen at the end of the use stage, or when we want to like make it to work different way. Like in this case, it's a domestic residential activist building, but maybe in later stage it will become an office when it's like in a key position at the city. So that's why the structure designer and the architect should like do optional designs. For this case, we have the original design option with the internal and external walls are load bearing, and we have this Kerto Ripa open box slab, which means at the right corner we can see this where the Sweco sign, that kind of structure. But then we have to like start considering other options, like do we want to use CLT or LVL walls, or do we make the intermediate floors also out of CLT? And there's also the concrete option, of course, because it's very familiar with the structure design companies, they might want to do it that way. And also we can do this mix and match option where we combine the concrete structures with the CLT or wood structures. So we can like play with the idea which one is better. So then we have this first step. We have to define the goals. At the first stage, we had the original design, which was for the less loads and smaller cross sections. But we decided we want more adaptability in the future, which means less load-bearing partition walls. But in the same time, when we are taking out those load-bearing walls, it means more stabilizing gravity loads for the walls, but still the shear forces will increase. So we have to check also that aspect when we are doing it. So here comes the engineering part. When we have those load options, like in the last slide, we have to check which one produces the most of the loads. Like for the wood case, there's the 3, 4, and 5 options. And if we compare them to other options, we can see that with the concrete solution, the load-bearing walls might have to bear more loads from the vertical gravity loads. But at the same time, if we change the walls to the design option of concrete walls and wood floor, we still might get the similar kind of loads in the structure. So it might become an even match in that way. And when we look at the big picture, what is the load combinations for these different solutions? Then we can see that there's not that much a big of difference between these, but with the concrete, naturally we get more vertical loads from these, but however we get smaller tension forces. So it means less anchoring, like connections, or difficult in detailing. So we can choose the best one, which means in this case that we want to do the design option 5 for the wood, CLT, LVL option, or with the combined mix and match of concrete walls and wood intermediate wall floors. So we end up with these options, but it's not like the single solution for that. There might be like a mix of loads option for 3 and 4, which might be much better in an overall scale than the previous ones. So it's up to the designer how he wants it. But when we look at the carbon footprint of these design solutions, like we know that the wood is a low carbon construction material, but when we look at the bigger picture, we can see like if we combine concrete walls with wood floors, we might get the almost similar carbon footprint. And by defining the goal of adaptability for the future, it doesn't like increase the demand in a large way. Like in here at the left side columns, we can see that the original wood design per cross floor area, it means that it's only 20 kilos smaller than the CLT LVL design option. And same goes with the concrete wood option, which means that it's like best to do the overall like comparison and not to be like only wood, only concrete, or nothing between those. And naturally the concrete is the biggest one with the carbon footprint. And when we like start chopping down what caused this effect, then we can see like with the wood construction, the carbon footprint of the structure frame itself is quite small, but we have to do some maintenance, meaning that we have the gypsum boards on the floors or the ceilings or in the walls. They require some maintenance, and same goes with the facades and so on. So you should like take the look at the bigger picture before you are like just doing comparison between these. And when we go even more into detail, we can see the intermediate floor in this color. Is it like dark brown, light brown color? We can see it's contributing the most. So the most effective way is to chop down the most contributing parts, and then we can like start concentrating at the less significant parts. And there's the overall results also for this building, which means that the wood building, like Matti said in his presentation, it was 300 square meters, but because of the energy usage on this area, we could easily cut off this carbon footprint of this building by concentrating first in the energy use, and then we can skip to the construction materials to be cut off. And here's the use stage energy, where we can like affect it by orientation, shape of the building, and like Rick said in the previous presentation, also the shade trees, how we put them in the area, how they shade the building, what is the green facades, how they can be used also. So doing the overall results and like focusing on the most important parts, we can also do savings on money and increase the efficiency that way for the buildings. Okay, thank you. And here are our details. And I'm sorry for spamming you with the emails previously.
Actually, we're very happy that you spammed us with emails and gave us the instructions to joining this meeting. Anyway, thanks a lot for this more engineering insights on what is the effect of choices. With that, we have arrived, we've concluded our last presentation. So I want to thank all of our presenters very much, especially as you made my job very, very easy. You kept the time, and now we have time for some questions. For those also who joined a bit later, if you have a question, I have seen no question in the chat so far, but if you want to ask a question to all the speakers or maybe to one of them, feel free to raise the hand and I will call you up. So you have now some time. Yes, I can see. No. Okay, this was no comment. Then, while people are maybe still thinking, I would like to pose one question to all speakers. I would like to have a comment, very brief comment from all of you on, no matter like, we have heard now a lot of different examples and concepts and ideas, and apparently there's a lot of solutions for low carbon construction. However, to make them a reality, what are currently the main influencing factors to choose low construction solutions in main construction? So what are the reactions, for example, from investors or from future clients? What is advancing or what is hindering? Can you maybe give some examples? Who wants to start? With all those volunteers, let's maybe start with Matti, as I can see him in the middle of my screen. What would you say are the influencing factors to choose low carbon construction in a building reality?
Yes, well, at the moment, I believe that it's still the price, and the price at the moment has nothing necessarily to do with the carbon footprint of products because of a well-known market failure that the externalities are not included in the price. However, there are forward-thinking investors and forward-thinking construction companies and product developers who are really motivated and really accountable in this manner. So if they follow their own or some other accountability policy, then this sets an ambition. And what's positive is that we also have some banks now offering green funding for projects that are either environmentally or socially more accountable than average projects. And this is, in my opinion, one of the most potential ways of boosting low carbon construction beyond the minimum requirements that we have in the legislation today or tomorrow.
Okay, thanks a lot. May I ask Satu, what are your experiences? You had some examples from Kalasatama and so on. So what is the reaction from well, people who are applying to submit a tender?
Yeah, thank you. That was actually what Matti said was actually very good, and I can continue from that. Because I see that the market dialogue is very important at the moment. There are a lot of very ambitious construction companies at the moment. And if I give an example from the low emission construction site project, for example, we had very good market dialogue with the market, and it became very clear that they were already waiting for us to put those criteria there. And they, for example, when we asked them whether they had like those electric construction machines, they didn't have them in January. But after we did the market dialogue, they had them available already in May when we put the tenders out. So the market dialogue is very important. And as a municipality, of course, I can say that we are using public money, so we really need to take other aspects into account as well, as not just money, but other aspects as well. And we really need to be more ambitious in our climate targets.
Do you think there's a market for that also, under like not public funding, but would people buy it? Because I mean, if you think like in a use phase, there's less heating costs, less other impacts.
Yeah, for sure. Yes, we just need to make these things visible for the people better, I would say.
All right, thanks a lot. Mikko and Mika, do you have some comments to follow up from your projects? Something to add up on this discussion?
Yeah. All right. Have to mention also that because we are representing the educational and research side, so I would say there is still a lack of know-how related to this subject amongst the developers, but also designers and builders. So that issue is something what we have to fix as well. And of course, there is those assessment methods for the emissions, life cycles emissions are also developing at the moment. So maybe this process has to be carried out to the final stage. So after that, maybe it's when we have a clear guidance how to calculate the emissions and so on and so forth, and how to compare those. So maybe it's much more easier and natural that way. And of course, also there is a end user role, the people who are buying, for instance, the apartments. So their conscience should be also on the level that they are demanding that the emissions of the apartments or the buildings has been kind of decreased somehow.
All right, thank you very much. Following up on that, I would like to pose a similar question also to Pekka. I mean, Pekka, you've been working a lot on providing information on the advantages of wood and substitution factors. Have you seen any change recently through the work? Are there some reactions at policy level, at practical level? Would you like to elaborate?
Well, at least we discuss a lot on wood construction, how to promote that why we are so much behind Sweden in the comparison, for example. But maybe a couple of issues that I could still take up that maybe was not mentioned. So one issue is that I guess that the municipalities as such, they have a key role in Finland, that how much wood construction can be promoted, and then the price issue, of course, that is understandable. If the price difference is say 5 or 10%, then of course given the current economic situation in general, of course that can be critical. But then, especially in areas like Joensuu, basically we are living in the middle of the wilderness and middle of the forest, and also somehow try to include the potential local value added, or the regional value added, that could be at least partly compensate the value difference. So that is something that might work in this financial aspects. And then second issue that I'm somehow in some cases involved in the discussion of different, let's say, climate compensation mechanisms, that typically in a global scale they invest into forest plantations, create new afforestation in different places, and those issues work, and there's quite a lot of different mechanisms under development. I don't know how unrealistic it would be to assume that part of this type of funds could be invested to wood construction for obvious purposes that we discussed. That might be one option. At least I have not heard anything on this. Then of course the topic that was mentioned also, the price difference, that these externalities are missing from the when you observe the prices of the market, that you don't have to pay for the emissions. That is, of course, is one of the key issue here.
Right, thanks. And the same question then also still to Rick, but more on the use of urban forest. What do you see as influencing the decision making of including it in city building or city construction?
That's an interesting question, Diana. Thank you. Well, one of the issues is that there's still a lot of complexity or conflict involved with trees in cities. I think people in city administrations, green departments receive a lot of complaints on falling trees and so on, or trees blocking lights on solar panels and in houses on the one hand. On the other hand, all the benefits that I have been mentioning are much less known. That's one point. And from a financial perspective, the benefits come for free. The management of trees, urban trees, is not for free, not at all for free, and it's more expensive to manage an urban tree than to manage a forest tree. That's one issue. Also, well, and for the manager of a site, being it a public manager or a private manager, he has to pay for the management, but the benefits are, well, less unknown, or they're very valuable, but they are not paid for in real euros. So that's really still an issue that's important to look into and to find a solution.
Right, thanks a lot for these reactions. Then I have a question from Clive Afanido to Satu Turula from the chat. How do you see other Finnish municipalities following the ambitious public procurement targets of the city of Helsinki? Satu, can you maybe answer once again?
Yes, I can. I just wrote down the answer as well, but yeah, this was very good question, and thanks a lot for that. So I would say that we do a lot of cooperation with the biggest, like the 6 biggest municipalities in Finland at least. And in metropolitan area of Finland, so we have cities of Helsinki, Vantaa, and Espoo. We try to develop the same kind of criteria to sort of give the market the clear signal that we are moving towards these goals, and we are doing it by these criteria. And I think it is very, very important as well for the market also to be able to see where we are going and when. And also I mentioned that, for example, city of Turku has even more ambitious targets than us. So
very well done. Thanks a lot for this. With this, we come to the end of our session, and I would like to hand over to Erkki Verkasalo to give the final words. Erkki is a professor of wood science and technology and leads the team of business opportunities unit at LUKI, the Finnish Natural Resource Institute. And the number one issue of his work is the basics applications of raw material and the product on the one hand side, and the knowledge sharing and technology transfer with stakeholders of wood products on the other side. So based on this very detailed understanding, he will give now the summary words of today's meeting. Erkki, the floor is yours.
Thank you, Diana. First, I would like to thank the organizers for inviting me to this interesting but also challenging task after these interesting presentations. But first, I would like to raise 3 issues that didn't really come out very clearly before in these presentations. At the same time, this is a kind of, say, complementary part here. That I would say that firstly, wood construction really is a part of a bigger economic sector of construction in Europe, and as it came clearly out from the presentations, it has an important role in the build-up of a circular economy and carbon neutrality, and anything where we try to combat climate change in the future. But at the same time, we should remember the 4-angle sustainability functions. That means important role to give job opportunities, to keep the rural areas together with urban areas living in Europe, and also contribute to the extraction of different raw materials. And that is something that is so close to the circular economy. Both material and energy is a big part, but also use of water is important in the processing stages of the whole wood processing sector. Of course, more in chemical wood industries than others. Anyway, in EU 28, roughly 1/3 of wood wastes still are recycled and materials as materials incinerated and landfilled each. So this is important to remember, that we have to take care of the side streams as well in circular economy. We do have big difference between the countries as regards the operational environment, historic background and industry structure and so far. But anyway, in Europe we have also common items that we can learn from each other. About the European programs, construction, demolition and new bio-based products represent 2 of the 5 priority areas of the European Union's action plan for the circular economy, which is important to remember. Secondly, nobody has yet been boosting so much for wood as a construction material, but there are several points in this list prepared by me and Henrik Herajärvi from LUKE. We have 8 different points which start from renewability, recyclability and availability for uses in industrial scales, and end up really to today's theme, helping climate in 3 ways. Wood growth of 1 cubic meter results in about 0.8 tons of carbon sequestration, and in addition 0.7 tons of oxygen release. And the uses of the final products result in long-term binding of carbon, as it was shown today in many respects. Then we have unfortunately a very long value chain, starting from the product manufacturing and ending up to the recycling and reusing of the materials. And it is important to remember that there are several different stakeholder groups along this way, and also several different materials, products and services to be combined. Sometimes it is difficult to deal with the information flows between the different stakeholder groups and actions here also from the policy development point of view. So as regards today's presentations, I would like to highlight some important parts of each presentation. First, Pekka Leskinen was talking about the substitution.
Erkki, we just lost you. Yeah, he just dropped out. Let's hope he's back. Erkki, are you back?
Yes, I am back again. Can you hear me?
Yeah, we heard me with Pekka Leskinen.
Okay, was my last word really. So substitution effects are really a must that should be taken into account and also be benefited by the wood product sector and wood construction sector as itself, but a holistic approach in the four-angle sustainability approach is something that is needed here. So Pekka was wise to stress that in his three key message list that we are talking about different perspectives to this view and different actions that are needed. Then an interesting part of the first presentation is about the urban forests, and what was interesting to notice here that there are both urban trees and other vegetations that grow on the ground, that means soil, and also the say green roof, green deck, green terrace, and etc. way of increase the greenness of the buildings. I would say that there are different places and different urban or rural sites where these activities could be applied. It is clear that in densely populated areas, the green roofs and decks are something to raise up, but here in the north, we are living in a different condition. That means probably it is still more important to take care of the green vegetation and infrastructure around the buildings on construction sites and leave also space for them in the design stage of the buildings.
2 minutes.
Okay, then about Matti Kuittinen's speech, it was so important to show that we only cannot speak about efficiency, but premises come first, and after that sufficiency and efficiency. And very nice to hear that this idea has been split to different functions already now, and we are just waiting for the different solutions how to activate these carbon storage incentives and regulatory and policy measures that have been planned. Satu Turula from Helsinki City showed an interesting approach toward both functionalities, carbon neutrality, and also circular and sharing economy. Sharing economy didn't really come up so clearly in this presentation, but it is interesting to show that circularity and sharing principles were connected together. We all, or most of us in Finland, know Kalasatama example and how these interesting mark green factor and carbon footprint factors have been done. And just congratulations for this way that you have now chosen together with the other 6 bigger cities in this country. Then at the last, as a sugar at the bottom, Mikko and Mika showed the technical perspectives, how to improve the carbon neutrality. And we found a different, very technically oriented and also detailed ways how to see. And it was very interesting to see that the things are proceeding also in this way. Finally, I would like to thank also the organizers and the moderator for the fluent direction of this webinar, and show my gratitude for this opportunity to say some words in this webinar. So thank you for the listeners, and now I would like to pass the floor again to Diana for the last messages of this webinar. Thank you.
Thanks a lot. I can just follow what Erkki just said. It has been a very interesting discussion and a very nice dialogue, and I'm very happy and thankful for both the listeners, but also for the discussion in the chat function and for the presenters. As we said, the meeting has been recorded and will be shared later on YouTube and on the Karelia website, and the presentations will be accessible under this link. And with that, I thank you all and have a very nice day. Goodbye.